Yeah, so hello, good afternoon, everybody. Welcome to this webinar that we organize each month. This time we talk about traffic lights and cycling, and I've invited my colleague Gonzalo here. So he will introduce himself a bit. So it's a bit strange talking to you and then having you sitting next to here and perhaps having you overlooking us together. But it will be a nice little cozy session of about 30 minutes. A bit about this webinar. We will move over for the practice part, traffic lights and cycling, and some information on how to continue learning. Perhaps some of you have heard this story before. We both work at a company called DTV Consultants. We specialize in cycling and safety. One of the things that we are particularly proud of is the development of the current edition of the bike design manual, or the bicycle manual for the manual for bicycle traffic. We do a lot of studies in the Netherlands, Europe, and beyond. And one of the things that we combine this cycling expertise with is our knowledge to do trainings and knowledge sharing. So we have been doing trainings for professionals for more than 25 years now. So we combine didactical skills with our substance matter expertise. And we, in the end, create smiles, as you can see on this picture. We are a member of the Dutch Cycling Embassy, so perhaps you became aware about this opportunity through their networks. It's an umbrella organization that collects a lot of knowledge and expertise, a lot of organizations, public, private knowledge, etc., from the Netherlands about cycling. So this is a bit about the webinar, and really short, of course. We will head over to Gonzalo in 1 or 2 seconds. But before I hand over the floor to you, Gonzalo, if you could share a bit about yourself, perhaps where you are located, what you do in regard to cycling. If you could share a bit in the chat, that would be really helpful and nice. As mentioned, we will have time for Q&As and discussion at the end of the session. So in case you have questions, please share them in the chat already, so we won't forget about them. So without further ado, Gonzalo, the pressure is all mine to hand over the floor to you.
Okay, thank you, Sai, very much. And hello, everyone. Good afternoon, good morning, probably less good evening for all of you, depending on where you are in the world. The idea of this webinar is to talk a little bit about how traffic lights and cycling are related and how we in the world have probably the same situation happen, but the approach of solving these solutions may be different in the Netherlands, for instance, than in the rest of the world. So that's the basis of the webinar. I'm Gonzalo. I work, as I said, in DTV Consultants, but my background is I'm Argentinian. I come from Argentina. I work in the city of Buenos Aires, the capital of Argentina, for more than 5 years. And also with traffic lights, with other type of transportation, but mainly also in the planning of the city, the transportation of the city. So I have a broad spectrum of knowledge of how things are solved outside of the Netherlands. And also I've been working here in DTV for almost 2 years now. So also I have a lot of information on how the Netherlands handles traffic lights, which is hugely different from the rest of the world, and how the two differences and what we can learn and what we can apply from one another to solve these solutions, to solve these problems, sorry. So, of course, the outline of the webinar, the idea is to go really quickly and really skim through the topics, don't go too much into detail. But if you, after that, you have any questions, of course, as Taya said, you have the Q&A at the end of the session, so we can talk a little bit more in detail if you have any questions particular. First, as a planner, I need to start talking about road hierarchy and how traffic placement is one of the main important issues, where you need to place a traffic light and why you place traffic lights. Then different components of the traffic light in the Netherlands and in the rest of the world, how that affects the cycle times of the traffic light, what are the clearance times and how the Netherlands and the rest of the world, they calculate this slightly different. also handling potential conflicts with other vehicles, but also with cyclists and pedestrians, of course. And at the end, just a small summary to like a quick ping pong of what are the takeaways or the summary of this. So of course, as I said, first thing is road hierarchy, and probably all of you have seen this 1,000, 2,000 times previously. But the idea of road hierarchy is dividing the type of road depending on the function of the road, if it's more movement oriented or more access oriented. And of course, on one scale is the network of highways that we all know. And on the other end is the cul-de-sac that there's no movement, it's just access. And in between, of course, you have the national roads, provincial roads, arterial, collectors, local roads. And in general, the traffic lights should be placed when you meet one arterial with another, one collector with an arterial, and that's about it. Also, maybe if two collectors meet, depending on which type of collector, etc. And then for local roads, those are smaller roads with less traffic. Normally, you wouldn't put a traffic light with two local roads connecting to each other. But coming from Buenos Aires, as I said, the road hierarchy here is like a typical grid city, a typical American city. You can see like 100 meters apart, there's one road, mainly one-way roads. And then in the top right, you can see the highway, the entrance to the city. And then you meet the first arterial roads. Then you meet the avenues, if we call them like that there. Those are mainly collector roads, and then all of the rest of the roads are local roads mainly. But what happens with the traffic placement? Here you can see these stars that I put are the only intersections in this part of the city that do not have a traffic light. So mainly in grid systems, the traffic light is mandatory or really necessary because it needs to handle traffic that it goes any way it goes. So here is like the summary of where in Buenos Aires and in many other grid systems like New York and other big cities, where the traffic light is placed. And in most cases is pretty much everywhere because of the amount of traffic that it goes through there, and also in a way the lack of road hierarchy, because any car could take any road, then all the roads become busy, so you need traffic light to allow different vehicles to cross the intersection. But of course, in the Netherlands, this is not exactly the same. And this is an example from Rotterdam. And you can see also on top the highway and how the highway connects to the more residential zones of the city. Then you have the arterial roads, also the collector roads, and once again, all the roads that they don't have any color, those are the local roads. But in this case, this is just the traffic lights used in almost the same area in the Netherlands. So you have one traffic light with the connection for the highway because it's a busy intersection, so you need to give way, and it's mainly high-speed roads. But then also we have a collector with an arterial. There you have a traffic light. Then there's not much more. Also arterial with arterial, of course, traffic lights, not much else. So there are other big intersections, which is like a collector with another collector. And in those cases, there are other types of solutions, like for instance, a roundabout or a different level solution. When you see the two arterials on the top right below the train tracks. So in the Netherlands, you have less traffic lights, more further apart of each other. And of course, those intersections are bigger intersections, more important intersections. So you need a more robust traffic light regulation to handle this sort of intersection. So that's the idea behind the traffic lights of the Netherlands and the rest of the world. Now, in the components of the traffic light in particular, in the rest of the world, mainly you have one traffic light for each direction of travel. Is not one per lane. So multiple lanes have the same traffic light, the actual light. Then in most cases, in the grid system, of course, left turns are not really possible in each intersection on each traffic light. This is usually, we use the city loop, you take a right turn, a right turn, and a right turn instead of turning one left turn, because also there are a lot more conflicts with the left turns. And then there are mainly dedicated pedestrian lights where there is a pedestrian crossing. And then, of course, in other intersections, bigger or different sort of intersections, you do have a dedicated left turn lane, and also you have pedestrians push buttons to ask for a green light for the pedestrian. But this is not used in every intersection in the world. But of course, going back again to the Netherlands case, you typically have one traffic light per lane. So each lane has one traffic light dedicated to that lane. We will look a little bit later why you need one lane per one traffic light per lane. You tend to have dedicated turning lanes because also as I told you, there are more robust intersections, there are bigger intersections, so you need more space to handle different sort of traffic. And also because the intersections are further apart, those left turns, if you don't have the left turn, the route that the vehicle had to turn is a lot longer than with the normal grid. So it's really interesting to have left turns. Then you always have dedicated pedestrian and bicycle lights. Those are different sort of lights. It's not the same light for both type of vehicles. And then mainly in the bottom part, those are in green, but normally they don't have color. Those are induction loops. They detect metal, or the vehicle in this case. So the traffic light knows when there is a vehicle approaching the intersection, how long has it been there, and what amount of vehicles are in each lane and what they want to do. That's also why you need dedicated turning lanes. And then you have in all intersections also push buttons above of the induction loops that also detect cyclists. You have push buttons for cyclists and for pedestrians. And then in the case that there is a highway speed lane or something similar to that for buses and trams, you have a dedicated also light for trams and for buses. And finally, with the new intelligent traffic lights in the Netherlands, you also have the ability to connect with smart cars. So the smart card sends a notification to the traffic light, and then the traffic lights know before the induction loops that this sort of vehicle is coming to the intersection. So that's also a huge difference with other type of intersections. In terms of cycle times, as I told before, the grid is mainly one of the main definitions of the system of traffic lights in main cities. What you usually have is you have big avenues, those are the yellow arrows, and you have then smaller roads in between. So what you need to do to get that system moving and not a grid block, as it is called, you need to coordinate those. So to make that coordination, you need, of course, distance and the time. Then you need to know where those intersections are placed, and you need to give them green and red in different sort of times in between each other. And that gives you in general a coordination speed between the traffic lights, so the cars can move through multiple intersections in one go. They don't have to stop every 100 meters. That's also a little bit more efficient. But that also takes a little bit of time and takes a little of coordination. So you need to coordinate mainly the big avenues, the collector roads, and then the local roads in between. They get the time they get, and it's not much you can do about those. You can compensate with longer cycles or shorter cycles, but then once the grid is defined and the cycle time is defined mainly between 190 or 120 seconds, that's the cycle time you have in the whole area of the city. And it's mainly defined through the peak hour of traffic, of course, the coordination, the speed that the cars could travel in those areas, and of course the distance between the intersections. In the Netherlands, as I talked before, you have different induction loops, and you have a traffic dependent system. You can send notifications to the traffic light knowing that a car is there, a pedestrian is there, a cyclist is there, and you can know that before the actual vehicle or pedestrian reaches the intersection. So in this case, the cycle times in the Netherlands are constantly being calculated and changed. So maybe one cycle time is 67 seconds, and the next cycle in the same traffic light is 72 seconds. but that's mainly because each step in the traffic light is calculating how many cars are there, how many cyclists are there, which directions are in conflict in each movement, and you have different parameters that you can change it. How much time you want a pedestrian or a cyclist to be waiting there, or a vehicle or a bus to be waiting there. So to make it the most as efficient as you could, you constantly iterate and change how long is the cycle time for each traffic light at each instance. That's a big difference. And another difference is the clearance times. Sorry, a little bit of water. In general, of course, we use the intergreen time, the intergreen clearance, and it's the time that passes between a car leaving the intersection fully and the other direction of travel is allowed to go. The idea behind these intergreen times, of these clearance times, is to eliminate or limit the conflict between the vehicles, and of course, pedestrians and cyclists. Tends to depend on the design of the intersection in general, depends on the size and the amount of lanes, etc., of the intersection. And in general, internationally, the vehicle needs to clear completely intersection before otherwise are allowed to go in. This shows ideally what is the clearance time and what is the conflict zone for this sort of intersections. What you can see that internationally, the time calculated is for the whole lanes crossing the whole other road before the next road is allowed to go. So that difference is kind of big if you also compare it to how the Netherlands calculate its intergreens and clearance times. And for the Netherlands, what we tend to do, is also to eliminate this conflict between the signal groups, just not now the whole direction of travel, but just specifically which lane is being used at what time. So you can calculate the intergreen time between a left turn and a straight lane, or a pedestrian with a straight lane, or a cyclist with a right turn, etc. So what you get is the matrix that is below. That is the intergreen time for all the signal groups or all the lanes or different types of movements that can happen at any points in the intersection. This is also one of the main parameters that is used for the traffic light to calculate the cycle time and to allow for the conflict vehicle or pedestrian or cyclist to completely free the intersection before the other lane of travel can get to that conflict zone. The difference mainly between the Netherlands and the rest of the world is that the conflict zone in the Netherlands is just the point you can see where the violet and the green lines touch. And in the international cases, mainly the whole intersection needs to be cleared. So in the Netherlands, you calculate specifically where they meet and how much time the next movement is going to take to get there. So in some cases, the intergreen time can be actually negative. It's not really used. In those cases, we usually put 0. So you have also a level of safety in that regard. But it's really important that you reduce the amount of time that is lost for all people traveling through the intersection. That's really important because the pedestrian, the cyclist, and also the cars wait less. And these are sort of intersections if you use the whole clearance time for all the vehicles. Now, finally, handling these potential conflicts that we talk about. And internationally, what's the main rule is the right of way. In general, when the car is turning right and a pedestrian is on the zebra path, the pedestrian or the cyclist had the right of way. This proves to be a shared space in the crossing. It's not something completely safe. You depend on the vehicle traveling to respect the right of way and give way actually to the pedestrian or the cyclist. So it is safe because we live in cities and we don't die every single day. But in truth, it's not really a conflict-free interaction between cyclists, pedestrians, and the vehicles. And sometimes internationally, what it tends to happen to make this priority more explicit is to have a head start in the green time for pedestrians and cyclists. In this case, for example, this is what normally happens. You have in the bottom part, you have a straight ahead and a right turn, for instance. And they have green at the same time as the cyclist and the pedestrian on the right side. With the green start, what you get is you get first a little bit of green for the pedestrians and cyclists. Usually it's 2 seconds, 3 seconds, and then you give way to the rest of the cars. This provides an extra level of security, of clearance between the pedestrians and the cyclists. But it's important also to mention that this is just at the beginning of the cycle. So if a pedestrian arrives just 2 seconds after or 3 seconds after the beginning of the cycle, then they're in contrast with the vehicles turning. So that's also kind of problematic. This sort of solution is kind of complicated when you have a bigger and more complex intersections. And for that, I have a different solution used in Buenos Aires. This is one of the main intersections of Buenos Aires. It's a huge intersection. It used to be the widest avenue of the world. I don't know if we still maintain that record, if you can want to call that. But you can see from the top, it's a big avenue, a 5-lane avenue that before the photo is kind of old. Now it also has a cycle path on the left side. It's the right side of the image. But you have a really big right turn movement from here to the right. And of course, you have a lot of pedestrians walking. Usually, the zebra path would be right next to the intersection. But because of the amount of vehicles turning, you need to give way for the vehicles turning and also for the pedestrians. So what we tend to do, and a lot of cities tend to do the same thing, is to put the zebra path a couple of meters back. This is a huge example. It's like more than 20 meters back to allow for the cars to stop before the pedestrians. So here you have the pedestrians have green at the same time as cars, but cars take a couple of seconds before they reach here, and cars need to stop because there's another traffic light here. And when the pedestrians clear, of course, the intersection, then these vehicles are allowed to go. And because it's a grid system, they are all coordinated with the main movement of the vehicles. So there are ways to handle this sort of interaction between pedestrians and cyclists with different times and with the vehicles, but it takes a lot of space also. So space sometimes in the Netherlands, the big intersections you have space, and sometimes in the grid system, you don't have that much space, but you can still look for solutions and try to solve the problems in a similar way to clear the conflict of cars and cyclists. But of course, in the Netherlands, once again, the pedestrians and the cyclists get complete priority. Because of what we said before with the clearance times, you have your dedicated signal group, your dedicated lane, your dedicated push box, and your dedicated traffic light. So when you have green, there's almost guaranteed that no other car should be in the same way as you. There are some cases that you have some cars turning, but then the cars have a huge traffic light saying that they are in conflict with pedestrians and they need to give way, because that's really not usually the case in the Netherlands. But mainly, you have your own space, your own time. And of course, these parameters can be changed. How much time the pedestrian or the cyclist needs to wait in the traffic light can be calculated at each cycle time and can be with some parameters handled by the municipalities to make life better for cyclists and pedestrians at each intersection. And this is, for instance, an example of how a traffic light works in the Netherlands. You have multiple ways of travel, multiple signal groups go at the same time. It's not always the same green time with the same movement at the same time, because you know how many vehicles are in each lane. So you can give exactly the amount of time needed to clear the way and then let the other ones go. So this is mainly how, the example to how the traffic light works. Maybe you can go back one to play the animation once again. One book. So you can pay attention and see how you never have a green in conflict with another pedestrian or another vehicle in this case. If there is a conflict in the animation, that's my error, but it shouldn't be. So that's it. So mainly as a summary of what I've talked about, maybe it was a little bit more than 20 minutes, but that was the idea, to make it fast. The placement is important because traffic light, you need to place it only what is necessary. All interactions can be solved with the priority rules in general with the placement. Cyclists and pedestrians should have priority at all the intersections. And in the Netherlands, if you don't have a traffic light, cyclists and pedestrians have priority. That's why also it's nice to cycle here. The components, you can adjust the regulations at each intersection at each moment. Also, you can program the traffic light to reduce the waiting times for all the groups you want. Specifically for cyclists, you can reduce the amount of time that they need to wait in the intersection. And because you're actually viewing or knowing when the traffic is arriving, you can actually give them green before they arrive to the intersection. So cyclists even don't have to stop at the intersection. That is something that we're also working on in DTV. In the cycle times, of course, are constantly calculated and adjusted based on the actual demand at each point. Shorter cycle times also reduce the waiting time for all users, specifically for us, for cyclists and pedestrians, but also for cars is a better solution. And also, multiple parameters can be adjusted to reduce the time of waiting and the traffic light for each vehicle. How you calculate the clearance times is really important to actually allow the other vehicle in conflict to leave the intersection before another vehicle, people move into the intersection. But it's important to calculate them really, really well with the correct speeds. And of course, the final idea is to limit the potential conflicts that you can have between cyclists, pedestrians, and other vehicles. So those are the main points that I wanted to share as a summary. That's it.
Yeah. Thank you very much, Gonzalo. Before we go into the Q&A, just some final words from my side. I hope this was really useful already, that you learned a lot already, and well, a little bit related to traffic lights or intersections and design. So this is a great opportunity to learn more about cycling infrastructure design. We are organizing our annual course upcoming July, which is well, approaching fastly. So if you have the opportunity, we still have some seats left. First week of July, visit our training for our website to get more information about our training, download the study guide, and also to watch a great after movie. As part of this training, we will touch upon design, go into intersection design, and also, well, reiterate some of the elements of all the things about traffic lights and things Gonzalo was explaining. Yeah, so this is just a summary. I will include this in the handout. It's now also part of the recording, so you have that there.